Marathon supershoes. We've seen this study last week. We have an experiment with a match pair design in which the runners run either with traditional marathon shoes, the streak, or with the marathon supershoe, the Vaporfly. We are told that the objective of the study is to compare the energy cost of running with those two types of running shoes. Because we have a match pair design, we have the individual difference in energy cost of running, so the differential in cost. That's the variable we are interested in. Our hypotheses are going to be about something hypothetical, something we do not know, which is what is the average energy cost differential for all male elite marathon runners, parameter mu-diff. The null hypothesis, as a statement of no effect, will say that in this population, the average difference in energy cost is 0. It makes no difference on average in this population whether the runners are wearing the streak versus the Vaporfly shoes. And so this translates mathematically into the statement H0 column mu-diff equals 0. Now we have to decide whether the alternative hypothesis is directional or non-directional. We are told that the objective of the study is simply to compare the energy cost of running with those two types of shoes. So that's a neutral statement, which corresponds to a neutral, so non-directional alternative hypothesis. So our alternative here is that in this population, the mean differential in energy cost of running is not 0. And so mathematically, this translates into HA column mu-diff not equal to 0. All right, so we have established our null and alternative hypothesis. We saw last week that the conditions for inference are met. So we will now obtain the p-value for this test. We can either do a match pair t-test on the individual columns for the energy cost with the streak and with the Vaporfly, or we can do a one-sample t-test on the already computed pairwise differences, the diff column. So for instance, if we go to statistics, t paired, so in this match pair t-test, for the first variable, we will select streak. For the second variable, Vaporfly, because we are interested in the difference streak minus Vaporfly. We need to define our null hypothesis. Notice it says mean difference under the null hypothesis, so that's our mu-diff, and we stated mu-diff equals 0. And then we need to define the direction of our alternative. So in this case here, two-sided, so non-directional, mu-diff not equal to 0. We get some summary statistics. The t statistic, which is the test statistic, 11.89. And then we have something not very informative. It says p-value less than 0.0001. You can go to the menu, preferences, and where it says p-value cutoff, add a bunch of extra zeros. Then we have to run the same test again, t paired, etc. And this time we get a more precise p-value, 1.159 e negative 9, which is 1 in a billion. We would get exactly the same p-value if instead we had used menu statistics t one sample. In the sample, we would select the column diff s minus v. Notice that this time, for the hypothesis test, it says mean under null hypothesis. And that's because we're saying the population mean mu for the variable difference. So this is again mu diff. So we got a p-value of 1 e negative 9. That's 1 in a billion. What does this say mathematically? What this says is that if mu-diff was indeed equal to 0, the probability of obtaining sample data like what we got, or more extreme, further from 0 in either direction, then the probability of something like that happening would be 1 in a billion. So yes, that's not totally impossible, but that's really very, very unlikely. So therefore, the data are much more consistent with our alternative hypothesis that, yeah, no, the mean UDIF is not equal to 0 in this population. So in context, what does that tell us? That tells us that this particular study provides very strong evidence. Make sure you do cite your p-value, p equals 1e negative 9, that in the population of elite male marathon runners running at top marathon speeds on a treadmill with a traditional marathon shoe versus with the Vaporfly super shoe, the mean difference in energy cost of running is not 0 watts per kilogram. Or we could also say that the study provides very strong evidence that the energy cost of running on a treadmill at top marathon speeds differs on average with traditional running shoes versus Vaporfly super shoes in the population of elite male marathon runners. Now, the reason for selecting a two-sided non-directional alternative at the beginning was because we didn't have a specific reason to want to look for evidence only in one direction. Once you found evidence that the mean difference in energy cost is not 0 in this population, then you can say, well, what do the data indicate? So the data indicate that the mean difference is a positive, which means that the average energy cost in this population is lower with the Vaporfly super shoe. Now, what did we learn from this p-value, and how does that compare with what we learned last week using a confidence interval for MUDIF? The hypothesis test is designed to ask how strong is the evidence against a null statement of no effect, no difference. The answer is the evidence is really, really, really strong. The p-value is 1 in a billion. However, a tiny p-value does not imply that we have a big effect. In contrast, the confidence interval we computed last week provides information about what kind of energy cost differential are we talking about, what order of magnitude, and that provides the support for discussion of relevance and importance. And they end their article by saying that based on everything we know, they would have expected that using super shoes like the Vaporfly would translate into the ability to break the 2-hour marathon barrier that had remained in place for a very, very long time. That was at the time of the publication. And since then, the records have indeed been broken for male marathon runners. The p-value for the test of hypothesis would absolutely not allow us to have any such discussion.